Hello and welcome again to Chem in 3. Today we look at topic 9, oxidation reduction, looking at how to determine the oxidation state of a particular atom inside of a structure like NaBr or H2SO4 or FeSO4, how to determine first of all that oxidation number, how to decide if something is being oxidized or reduced based on the change in its oxidation state or its oxidation number, and how to understand reactions like these in terms of the reactivity series. So let's move in and take a closer look. And here we have NaBr, sodium bromide, reacting with chlorine to give sodium chloride and bromine gas. If this reaction actually happens in the lab, you would see a change in color as sodium bromide liberates bromine and it enters into aqueous solution to give you the characteristic brown color of bromine. So what's happening in terms of redox? Well, let's look here. Sodium has got a charge of +1, or an oxidation state of +1, +1 oxidation state. And here, sodium still has a +1 oxidation state in sodium bromide and in sodium chloride. So we can conclude that because there's no change in the oxidation state of sodium, that it's neither oxidized nor is it reduced. So let's look at the other substances reacting in this equation. And here you have bromine, Br negative, oxidation state -1, and here you have bromine now combined with another bromine, which means its oxidation state is 0. So the oxidation state change for bromine is from -1 to 0. That's an increase in its oxidation number, and oxidation can be defined as an increase in oxidation number. It can also be defined like this: Br minus, losing an electron to become Br, putting 2 here and putting 2 electrons on this side and putting 2 over here. Here we see that bromine has lost electrons in this half equation. Bromine's lost electrons, 2Br minus, 2Br here, and the 2 electrons here with the negative charge balancing off here. So what you have is a half equation that shows that bromine goes from oxidation state -1 to 0, and in so doing it loses electrons, oxidation is lost, it's lost electrons, and in so doing it's been oxidized. It means that if it's oxidized, it's actually behaving as a reducing agent because it releases electrons which can be used to react with chlorine. And when these electrons react with chlorine, then we get this equation. And this 2Cl minus here balances, of course, with the 2 electrons that are gained. Chlorine here going from gas which has 0 oxidation state, it's combined with another chlorine. You've got to know that from your rules of oxidation number, which we covered previously. And here now it goes from 0 to -1, a fall in oxidation number. And reduction is a fall in oxidation number. So we can say that chlorine is reduced by a gain of electrons, reduced by a fall in oxidation number. It's reduced, and of course, if it's reduced, it's behaving as an oxidizing agent, because when another species, the bromine, loses electrons, the chlorine is there to gain those electrons, and in so doing it's reduced, but it's behaving as an oxidizing agent, going from oxidation state 0 to oxidation state -1, a fall in oxidation number, and that is characteristic of reduction. Reduction, of course, can also be described as a gain of electrons, and that's happening here. RIG, reduction, is gain. Of course, one more thing to consider is why is it that bromine is displaced by chlorine? And that is because there's something called the reactivity series, where we can list fluorine as the most reactive of the halogens, followed by chlorine, followed by bromine, and followed by iodine. And therefore it means that in a reaction like this, chlorine being higher up on this reactivity series will displace bromine from sodium bromide and allow bromine to form here as aqueous bromine, which gives a characteristic brown color in the solution. So now I would like you to consider this question. Using the similar method to what I looked at here, and bearing in mind that there is a reactivity series here as well, where iron is above hydrogen in the reactivity series, so iron is capable of displacing hydrogen. You can see that the hydrogen is released here and the iron forms iron sulfate. So I would like you to follow a similar method to what I used in this question here, to identify changes in oxidation state, to identify oxidizing agent, reducing agent, and to produce half equations like I did here to show the process.